Hello everyone, my name is Stefanos Mazzini and I work for Balsamic. And we've been working with React for a long time, and Relay as long as it could possibly exist. And recently we've been playing with Relay and trying to really make it work. It's not in production yet because we're working on a new product, but I'm here to share what I learned on it. Hopefully you will like it. So why Relay? Well, it's got a few nice features. It basically sets itself as a replacement for Ajax. So it's a new way to fetch data from the server, and it's automatic. It's got a few nice properties. If you read in the GitHub page documentation, it's the collocation of queries and code, which is actually nice. Basically, you write your React code, and your component you can decorate it with information about what the data it needs from the server, which I think is pretty nice. And then it provides caching, so the interaction with the server is optimized because I found that it's really good for doing API mashups on the server. So if you have a microservices architecture, it's really good. And why not? Because we found ourselves in a situation of creating a new greenfield project, and so it's a perfect opportunity for learning new stuff. And we really wanted to give it a try and see to go and dive deep into possible problems and whatnot. So the usual questions are how to fetch the data from the server, how do you write the data to the server, and how do you handle URL routing? Maybe there's a different way to do that in Relay if it's got implications. That's also something that I wanted to find out. And I also wanted to find out how to do to manage application state because I've always been using Redux, and so I still wanted to do that. And how you propagate server-side push notifications if you want to do real-time collaboration, this sort of things. So these are the questions that I wanted to get an answer for, and so we, as I said, we tried to go deeper into that. But first, I pulled a few interesting statistics from GitHub, and this is lines of code of libraries. So we see React is about 10,000, 100,000 lines of code, and Relay and GraphQL together are about the same. And then there's a very tiny React router in Redux. And Redux actually is 7,000, but it's actually 100. Those of you who have been to the Dan Abramov talk a couple of weeks ago, it was really good. So, these are the stars in GitHub, and React is a lot, of course. And then there's quite a lot also for Redux, and far less for Relay and GraphQL. And I think part of the reason is that they're not so popular yet, and because it's relatively younger. And also more difficult to grasp this concept. And so, if you plot stars over line of code, and you think of React as the baseline for reference, then Redux you should definitely look into, because it's so tiny and so popular. The other ones, Relay and GraphQL, as I said, you got to be careful. There's already an indication to me, but it's lines of code and GitHub stars is not really serious, but just for fun. So anyway. Let's get to the meat of the top. So, how do you fetch data from the server? That's GraphQL. So, GraphQL is the transport protocol. It's just a protocol, and it can ideally be used outside of Relay. And indeed, having projects that have been created on top of GraphQL that have nothing to do with Relay. It's a way to replace, as I said, REST. And the goals are that requests are supposed to be space efficient, meaning that the client only gets the data that it needs and doesn't get everything that specific API entry point, REST API entry point is feeding. And therefore, it's also supposed to be computationally efficient because the server doesn't waste time computing stuff that the client doesn't need. And and I will quickly show you. This is going to be tricky. Very tricky. Are you going to be so kind? Thank you. So this, It is going to be really tricky. Now, it's going to be quick as well. So, this...
I cannot do much more.
Thank you. The nice thing about GraphQL is that when you implement a GraphQL server, you get for free this API, this entry point. So, if the server figures that you're querying the entry point using the browser instead of an AJAX call, then it feeds you with this UI for free, which is really good because you have a way to sort of a debugger. And GraphQL has auto-completion and introspection, so you can actually hit the right key, and you can do a query, and you can.
What about turning this side completely?
What?
No,
it's so and you have a general account is, as you can see in the description down here. It's the account of the logged user, and so you can ask for some stuff, maybe user, and then the data of the user. So I'm navigating my own data here, and I don't know, something like that. And if you query it, it will reply with the information. And if you change something, you take something away, and you query again, it will reply with only that information. So this is this is just a very simple example. I like to think of GraphQL as half JSON. Basically, it's think of it as JSON without the values, just the keys, right? So this is what GraphQL looks like. And so most importantly, GraphQL is a type system. So you have your model objects, and in my case, I have a user which has access to many sites, and each site has access to different projects. And so what you do when you want to implement a GraphQL server is you describe your types. And so you create these objects here that are totally separate objects than the ones you have in your model, but describe how your model works. And so you have a user type, you have a site type, you have a project type, and we have connections between the types. So from a user, you can go to sites with a one-to-many relationship, and so you also have a site of user type and projects of site type. And these are all objects that you have to describe. Once you've done that, you have a GraphQL server. And so this is just GraphQL. So this is what you want to do if you want to implement a generic GraphQL server. If you want to implement a Relay server, then you have further constraints, because each one of these types have to adhere to a specific interface. And specifically, these types have to be a node interface, and the connections have to express the edges interface. And this allows Relay to do caching, for example, because the node interface is what allows Relay to have a unique IDs on the objects, and then edges are what allows, for example, pagination, because Relay gives you pagination for free. So let's see an example of how this conceptually works when a Relay application works. So we have the React view on top and the server on the bottom. And so let's suppose that the user goes to the site, and so it logs in, and there's interaction with the server. And the information about the user comes back, and Relay caches that information. So now we have the user in the cache. The user goes and navigates further to the site, and now we have a site in the cache. And then from the site, you go to project 1, and then you change project, and you go to project 2. And that's time. There was an interaction with the server, because it's the first time you go there. But now, if you navigate back to project 1, then basically Relay figures that it has in the cache, and so it feeds the React view that information without going back to the server. And this is nice and dangerous, as you can imagine, because you have to be careful about when maybe project 1 was changed in the server. But if you do, then you get this caching validation for free, because the library takes care of that. And as you know, caching validation is a hard problem. So it does a really good job in doing in maintaining this client-side cache for objects. So this is what it looks like from 10,000 feet point of view. Now let's look at what the schema looks like, because a schema is what you implement to have a GraphQL server. So this is a little tiny. But I have no way to make it bigger. Sorry. So basically, when you implement a schema, you instantiate a new GraphQL schema, and then you have to implement a query. There's a little bit of boilerplate. And then it's got to have a name, and the name is always root query type, because that's how the schema begins. And then it has fields, which have to have this line called field. No field is something that comes from the library, so again, it's just boilerplate. And now finally we have some interesting stuff, which is log user, which is the one that I showed you before in the example. So this is the actual information that you can fetch. And as anything that you can fetch, it's got to have a type, so you specify the type, and this log user is meant to be a user, so it's got to be user type. User type is something that we have implemented, and I'll show you later on the screen. And then you have options to give a description, so that's what goes in the introspection description. And then we have the final interesting bit, which is the resolve function. The resolve function is a function that takes three parameters. The first two I'm not using now because this is a simple example. I'm using the third one, which is stupid but interesting, because there's the root value in the third parameter that contains every, let's say, global variable you want to feed into the machinery at startup. So when you start the relay machinery, you have the option to feed into the machine some stuff that you maybe find helpful later on. For example, the log user is something that I get from authentication, and so I make it available to every call this way. And so this is how you get stuff from the environment. A more interesting example is the actual user type. So let's see how it looks like. So we instantiate a new user type, we give it a name, which is of course user, and then it has to have this interface or interface. Fields, ID. The ID is something that, as I mentioned quickly earlier, is something that Relay is dependent upon. So every instance of every object needs to provide a unique ID. And the way you build it by using that global ID field helper function, you provide a string, which is user, that makes so that IDs of users are different than IDs of sites and different IDs from projects, for example. And then you have a function that, given your model object, provides something that can use as a unique ID. In my case, I already had something that was called ID in my object, so I just returned that. But if you have something else, like maybe email or anything that can use as a unique ID, then you can use it. And then again, node field, because of the interface contract. And now sites is something that we want to access from the user, right? So this is how you define it. Sites is a type of, the type is users in site connection. And that thing, user in site connection, is something you get from another helper function. So you just describe with this helper function that you want to connect users with sites, and you get back this object you just plug in there. So nothing really complicated there. And then the description. And then the resolve function. The resolve function is an interesting bit. And now I'm using all the three arguments. The first one is, well, the third one I fetch from the environment a DB, which is my reference to my helper functions that allow me to query the DB. And so I have this function here, get sites for a user, that is something just very simple that queries the database and fires an SQL query, given a user. And the user is the first argument. Now, the first argument is called user because now I know that I'm talking about a user, but really is just the instance of whatever we're describing with this type. Since we're describing users, then it's going to be a user, and I call the parameter user. If it was a site, I would call the parameter site. But then that's what you get in the first parameter, the instance. And then you can use it for do whatever you want. In my case, get size for a user is a helper function that returns a promise that resolves to an array. And so you wrap that with this helper function that's called connection from promise to array that knows how to wait for the promise and then get the array and turn it into something that works well with the user's site connection type. So again, it's just the boilerplate in a way. The documentation describes all the helper functions that you can use, depending whether you return a promise or not, or callback, whatever. And then the interesting bit is this args, because as I said, Relay offers pagination for free, and that's where you get the start and the limit parameters. So, so in this case, I'm making a stupid use of it because I'm not feeding it into the database, and so I'm always querying the whole table. But if you want to be smart, then you can actually query that table using args.start and args.leave. So this is how you implement a type. And it's all about this. So this is how you implement a GraphQL server. It's not that complicated once you get your mind wrapped around the concept of describing your model objects with types. So let's make a comparison with REST because there's a catch. So it's not. I think it's a very nice way to describe a model, but there's a catch. So let's see, for example, let's say we have this URL /user/14/all my sites, and it's supposed to return the whole thing. So all the information about the user, all the sites that the user has access to, and all the projects that belong to those sites. So the whole fat thing, right? So the way I would probably implement this is by using a query that joins together the three tables in my database, because it's the most efficient way to query the database in this case, right? The problem is that with GraphQL, that's not possible because it really depends on the query. So if REST was like REST API is a contract that in a way is akin to a compile time sort of decision, whereas GraphQL is runtime because this query, like for example this one, query user and then sites, is returning me these objects. But if I change the query and I add projects, I also have these information in my response, right? And this is cannot be possibly decided at compile time or like in the code. The code has to be able to work with both situations at runtime. And in fact, the way it works is that there's a resolve function that is giving me the sites belonging to that user, as we saw before. There's going to be probably another resolve function that goes from site to projects. And so those resolve functions are going to be called in sequence and by the library. And I will probably implement the first one with a select from sites, and the second one with a select from projects. But then the second one is going to be executed n times. So this really behaves like an OR of the stupid kind. So you got to be careful because it's not easy to work around this limitation. I asked a question in the forums, and some developer told me that in the third parameter you get a lot of goodies, including like the AST of the query. So you actually have access to the parsed version of the query, and so you can by the time you do this result, you can actually figure out that you're going to ask also for the projects. And so maybe you do a different query and then you return fat sites instead of the simple ones, but it's ugly. So it's an optimization that you can do if you really have to, but be aware that it's not like so simple. So it's as I said, it's really good for meshing up APIs, but like accessing a traditional database is tricky. I mean, it's tricky. It's simple, but maybe it comes with overhead. So how about writing? This was for reading, right? Writing is done with mutations. So the concept of mutation is, I'm not going to show you code because there's even more boilerplate involved, but it's not too complicated. The only important concept that I wanted to tell you is this. So basically, you have a client that is working with some information, maybe the site name. You want to change the site name, so you click on the site name, and maybe turns into an input field, and you change the input field, you hit enter, and at that time you fire the mutation, right? And the mutation really is yet another type you describe in your GraphQL schema, and the type just describes what is possible to change on the server, right? And so you may describe it, the site name can be changed. There's a site name change mutation. Fine. And so when you do that and you fire a mutation, a communication goes to the server with a new version of this red thing, the site name, whatever it is. And the server updates its own internal copy, and you have mutated the server. But then very often it happens that this mutation actually implies something else mutates. For example, the example you find in documentation from Facebook is like liking a post. Liking a post is going to change the like count of that post. So everyone who's looking at that post is going to see the like count increase by 1. And so maybe you have other elements that need to, are changed as a consequence to your mutation, right? And so what happens if your client is actually viewing one of those things in the UI? So Relay takes care of this in a very nice way, I think. Because basically it's able to figure out that you're viewing something that is that has possibly mutated as a consequence of your action. And it does it, so it sends it back. So in response to your mutation, it sends back the elements that need to be updated in your cache. So this is how it deals with cache validation. And it does it by means of this concept, which is the fat query. So when you describe a mutation and you say that you can update, change the site, the name of the site, you also have to provide the complete list of elements that could possibly change in response to that. And when you do that, you allow Relay to merge that information with whatever it is that you're currently viewing, and so it updates the internal cache. So this is the only tricky information that you need to get when you read documentation. Otherwise, it's pretty straightforward. So how about URL routing? So URL routing, let's go back a little bit before talking about that to how this looks like, Relay looks like on the client side, because I haven't shown you yet. So this is how a component looks like, Relay component. So you have a regular React component that accesses some information from the properties. But those information are made available by this decorator that specifies that you want to access a user, which is of type user, and then from that user you want to access the first name and the last name, because that's what you want to use inside the component. And as you can see, we're not accessing the sites, for example. And so this means that the sites are not going to be queried in the database, which is good. And so this is, it's a nice way to. This is what the documentation means when it says co-location of the code and data, because you see what data on the server side. In order for this to work, though, because we have a component and this wrapping that I just shown you is what makes it into a Relay container. In order for this to work, we haven't specified what user we're talking about, because that code that I showed you is just describing how to show a user, but which one we're talking about, it hasn't been specified yet, because it could be a logged user or maybe a generic user, because we're iterating over all the users on the site. You don't know. So what's missing is another part. It's called it's really called Relay route, but the name is sort of misleading, and it's there for historical reasons. But really, what it is just a query configuration. So basically, it says which user we're talking about. And once you do this nesting, then you have something that you can actually feed to React render, and it makes it into the DOM. So this is how rendering works. So if we go back to routing, and this is our example, so for example, /user, /14, /settings, if we want to use React Router, which is the library that's mostly popular out there, you probably want to have an application component that takes care of the slash, and it's going to have a nested user component that's going to show information about the user, and then you're going to have settings inside that user. And the way that these components have to be written, because of the way React Router works, is that they have to be composable. So application doesn't necessarily need to know that it's going to be fed a user, but it needs to be able to be composable. So it works with props children. And it is the React Router library that puts them together. If we want to naively make this work with Relay, we might think about just wrapping them with a decorator we just saw. So we decorate each one of those components with a Relay description of the data that they need. But as we saw, this isn't enough, because it's not telling which specific application we're talking about, which specific user, which specific settings. And so we need to wrap it again with the query configuration. But if we do it this way, then just showing this URL, this one page, will require 3 round trips to the server, because each one of these red boxes is going to query the server, which is highly suboptimal. So the solution is a library that's called React Router Relay, which simply implements a smarter version of the query configuration, which can be used as an overall container that knows how to traverse a React Router tree to find the Relay containers and collect all the fragments that need to be collected with respect to the same query. And so this is supposed to work, except that it doesn't work. Not very well. Not for me. I was able to to bring it down from 3 queries to 2 queries, but for some reason they're still stuck at 2 queries. I don't know why. So I'm sure it's me because I haven't played with this enough. But what I wanted to tell you is that don't approach this with a light headed because it's still rough on the edges. These libraries are still having a hard time catching up with each other in development. It's still quite immature somehow. So it's not trivial to get this stuff up and running. You're going to spend a little bit of time figuring out how to put things together. Now, application state. I'm a big fan of Redux, and the problem is that Redux and Relay, they both compete for application state management because they both want to have their own data store that's supposedly one to rule them all. And so it's hard. Maybe I thought maybe they could coexist. What if we make them coexist? It can work. For example, like the site name. We're doing a site, and the name is something that you fetch from the server, and therefore it lives in the Relay data store. And if you want to change it, maybe it's just a trick of clicking it, just turning the component into an input field, and then hit enter, fire the mutation, and you're done. So it could be just live in the Relay data store. Redux doesn't need to know about the existence of the site name, maybe. Projects in the site, again, the same thing. Maybe it's just a list of projects. Maybe that Redux doesn't need to know about their existence. On the other hand, a dialog, Relay doesn't need to know of the existence of a dialog. After all, it's just a boolean if it's shown or hidden, right? And it can very well live inside a component state, or it can live in a Redux data store if you have something more complicated, like, for example, a dialog that contains a very complicated form where maybe the user has to go through several pages and you want to keep track of the state of the application. So, but maybe this is something that can live inside the Redux data store without really knowing anything about it, because you just collect a temporary state, and then once the user clicks saves, then that's when you fire the mutation, and the information goes into the Relay realm. But then, what do you do with an existing project? If you want to edit an existing project, that's going to be tricky because a project is something that comes from the server, so it lives inside the Relay data store. But then, if you want to edit it in a complex way, then you need some Redux to handle the temporary management of the data. So it's not nice. And I haven't found a way to make it work in an elegant way. So everything that I came up with is kind of hacky and ugly to look at. So people don't seem to have reached the consensus yet. So it's something worth knowing about. But there's a way around. I mean, there's a way to make them work, but you have to be careful, and it's probably not going to be very nice. Finally, how do you propagate the server-side push notifications to the client? So, as we said, we have a client that communicates with the server, and the client has its own cache, and the client talks about the red object, the green object, the orange thing, and but then maybe you have another client on a different browser, on a different machine, that also is viewing the red object, right? And maybe you have another one that is viewing the green and the yellow. Wouldn't it be nice if the server knew about which client is viewing which object, so that when the first client changes the red, the second client is notified by the change, and the third one is notified as well. This is what's called the live queries, and in the forums they have been discussing this, whether to implement this in the library, because it would be very cool if the library took care of this magically. But unfortunately, this is not going to happen because it's too complicated. If the library was to figure out all of the implicit dependencies between, among the various parts of the data you have in your model, it would be too complicated. And like in the blog post that they have in the Relay blog, they describe a simple example of, again, liking a post. And they list at least 10 examples of events that may impact the like count. Like, for example, somebody just deletes the account on Facebook, that also impacts the like count. So it's pretty complicated if the library had to take care of this in a completely transparent way. So instead, they're shooting for something they call subscriptions, which are not here yet. They just made it to GraphQL, so GraphQL already knows about the operator subscription. And these are model software events. Basically, it's a way to cut the problem in half and just let the library deal with half of it, just the easy one, and let the hard part be on the developer shoulders. And so basically, your client, your browser, needs to know about which events are relevant to whatever you're currently showing, and must register and deregister for those events. And subscriptions are just a way to describe, it's just a type, yet another type, to describe what events the server is able to emit via GraphQL. And so you can register and deregister, and on the server side, you have to fire the right events at the right time. So in the piece of code where you actually change the database and you set the like on that post, you have to think about all the events that need to be fired, and you have to do that. So this is nothing different than what you would probably do anyway if you had to roll your own solution. But if people thought that maybe Relay was a magic solution to to solving this problem of real-time collaboration, it is not. Just be aware of that. So in the end, I like Relay and GraphQL. I like it very much, and we're trying to make this work into production. So it's still the code that we have is still we still call it proof of concept, but we're really working hard to make it production quality. And I think modeling this way has been really fun, and it just makes sense to describe your models with these types. I think it's really, really good abstraction. And I think it scales well if your problem is complex and maybe your project grows in complexity. And as probably is working well for Facebook. So really is awesome. But it's also very there are limitations. Some are temporary, some are not. So, for example, error handling is currently poorly implemented at the moment. So if you have a bug in your code and there's an unhandled exception, that's properly handled. So you have the exception bubbles up correctly and all the way up to the client. So you get an exception message, an exception string, message string, and a line number. But if you properly handle exceptions like in production, and you want to deal with corner cases with something that's more expressive than it's a single string, you cannot currently do it. GraphQL supports it, but Relay doesn't. So you're stuck with just a string representation and a line number. So there's no way to get a JSON, for example, representing the error condition. It's tricky to do that. And this is something that is likely to stay because it's part of the model. It behaves like it's hard to optimize database access, as I showed you. So it behaves like norm. Be aware of that. Then there's this thing about the root queries. For some reason, if you have more queries at the root level, they're all going to end up being separate network access, which is something that could be supposed to be easy to be fixed, but it's also easy to work around, and so they haven't done it yet. But it's something that annoys me sometimes, so I try to mention. And then this subscription thing is no magic is going to come. Just be aware of that. So yeah, all in all, React Relay is complex. The real question is your application also complex? Because if it is, then it's definitely worth giving it a try. If it's not, you may still want to learn a lot by looking into the stuff like I did. And we're still on the fence and trying to decide whether we want to use Relay or not. GraphQL maybe is going to stay, Relay I don't know, but it's so far it's working well. Otherwise, just stick with REST and Redux because they're working fine. So this was a very high-level overview. I'm done. And if you have more specific questions, feel free to stop by afterwards and talk about it. Thanks.